This section 5.3, trig functions of any angle. What does that refer to? Well, remember we found trig functions using a right triangle, but that only gives us, allowed us to find trig functions for acute angles. So this will allow us to find functions for any angle, like an angle of 120 degrees or something like that. Okay, so first, how will we define these? So the definition says let theta be in standard position with point P, which has coordinates xy on the terminal side. Then the distance from P to the origin is r equals the square root of x squared plus y squared. And we can see that if we were to have a point somewhere and connect the point to the origin with a segment, and then draw perpendiculars to the axes, right, which would be the distances x and y, we could see what that means. Okay, maybe we'll draw one just so we can see it. All right, so so the definitions are as follows: cosine theta is x over r, secant theta is y over, r over x. Notice that's the reciprocal. Sine theta is y over r, and cosecant theta is r over y, the reciprocal. Tangent theta is y over x, and cotangent theta is x over y. Again, reciprocals. All right, so we want to remember, especially cosine theta is x over r, sine theta is y over r, and tangent theta is y over x. Those are especially important because then the other ones are just the reciprocals. In particular, notice that r will always be a positive number because it's the distance from the origin to the point. So the sign will change according to the sign of x. I mean, the sign of the value of the cosine will change depending with what x is. So if x is positive, then the cosine will be positive. And if x is negative, then the cosine will be a negative value. Same thing with the sine of theta, right? If y is positive, then the sine of theta will be positive. And if y is negative, then the sine of theta will be negative. If you look at tangent of theta, y over x, well, that depends on the signs of those. So if they're both positive or they're both negative, then the tangent is positive. If one of them is negative and the other one positive, then the tangent will be negative. Notice, by the way, if they're both negative, that's quadrant 3. If they're both positive, that's quadrant 1. Yeah. So we can connect the quadrants where the terminal side is to the signs, the sign of the value of sine theta and cosine theta and tangent theta. All right. So sine theta will be negative in quadrants 3 and 4, and positive in quadrants 1 and 2, and cosine theta will be positive in quadrants 1 and 4, and negative in quadrants 2 and 3. All right, so let's just draw a picture of that. So let's pick a point in any quadrant. Let's say I pick a point in quadrant 2. If I pick a point in quadrant 2, some point somewhere. All right, so the x-coordinate goes from the origin to the left, and it's a distance of x, right, or the absolute value of x, and then the y-coordinate goes up to the point. This is in quadrant 2. So these are coordinates xy, and then r is the distance from the origin to the point. So there's r. Yeah. All right. So let's take a look at how we're going to use these. So the examples say find the values of the 6 trigonometric functions for an angle, not and angle, an angle, whose terminal side contains the point 2, negative 1. So first I'm going to do it without drawing any picture, and then we'll draw the picture just to see. So 2, negative 1, so x is 2, y is negative 1, r is the square root of 2 squared plus negative 1 squared, which is the square root of 5. Okay? All right. So let's find these. So sine theta is y over r, which will be negative 1 over the square root of 5. And again, don't forget we're rationalizing, so this is negative square root of 5 over 5. All right. And of course, the cosecant of theta would be the reciprocal, so it would be the negative square root of 5 over 1, right? Or negative square root of 5. cosine theta is x over r, which will be 2 over the square root of 5. We rationalize that'll be 2 square root of 5 over 5. Okay? Positive. And the secant would be the reciprocal, so the secant would be the square root of 5 over 2. All right. And then the tangent of theta is y over x. And in this case, y is negative 1 over 2. Yeah, that's it. And so the cotangent would be negative 2 over 1, which is negative 2. All right, we have found the 6 trig functions. Let me write them out. So cosecant theta, CSC, cosecant theta is negative square root of 5. Secant theta, the reciprocal of the cosine, is square root of 5 over 2. And finally, cotangent theta is the reciprocal of negative 1/2, which is negative 2. Okay, all right, we found all of them. And now let's go back and find where is 2, negative 1. We'll plot it. So 2, negative 1, as I go 2 to the right, 1 down, it's in quadrant 3. Quadrant 4, I'm sorry. In quadrant 4, x is positive, y is negative. X is associated with the cosine, because the cosine is x over r. And so therefore, they follow each other, right? Whatever sign x is, as far as positive or negative, is the sign that the cosine will have. So the x is positive, cosine is positive. Y is negative, sine is negative, right? And because one is positive and one is negative, tangent is negative. All right. Let's go on to number 2. It says find the sine, cosine, and tangent for each, and letter A is pi. And so where is pi? Well, pi, remember, is 180 degrees, right? Well, we don't have an x and an r, but we can pick one. We'll just pick negative 1, 0, right? That point is on the terminal side of pi radians, yeah? So negative 1, 0, and notice we can pick any point, okay? So x is negative 1, y is 0, and r is 1, right? The distance from the origin to negative 1, 0 is 1. Okay, so we can build then our sine, cosine, and tangent. So sine of pi, notice we don't say theta because we have a theta. Sine of pi is y over r, so it's 0 over 1, which is 0. Cosine of pi would be x over r, which is negative 1 over 1, which is negative 1. And then finally the tangent of pi, which is y over x, 0 over negative 1, is 0. Okay? All right. And we can also find the other one. So the reciprocal of sine is the cosecant, but that would be 1 over 0 is undefined. So the cosecant of pi is undefined. The secant will be the reciprocal of the cosine. Cosine is negative 1, so the secant is, of pi is negative 1. And the cotangent is the reciprocal of the tangent, so the cotangent will be negative 1 over 0, which is undefined. Right? So notice, right, sometimes you get undefined values when you have one of the values of x or y equal to 0. All right. And I'll leave letter B, which is 90 degrees. We're going to find sine, cosine, and tangent. And you would approach it in the same manner as I just did the sine, cosine, and tangent of pi. All right, let's go on to part 2, reference angles. All right, so let theta be in standard position. Then the reference angle for theta is the acute angle, theta prime. That means we're calling it theta prime, the reference angle, formed by the terminal side of theta and the horizontal axis. Yeah, that means the positive or negative x-axis. Notice it's theta prime is the acute angle. Yeah, is an acute angle. That means greater than 0 and less than 90. All right, so let's check to see we can find theta prime. So letter B says find reference angle theta prime for each. Number 1 is 330 degrees. And if you think about the rotation of 330 degrees, that's in the clockwise direction, which means from the positive x-axis you rotate counterclockwise. And you don't get to 360, you're 30 degrees away from 360. So that's the reference angle, 30 degrees. So theta prime is 30 degrees. All right, let's take a look at number 2, negative 5 pi over 3. Okay, so if you'll remember, 2 pi is a full rotation. This is in the negative direction though, so you're going from the positive x-axis downward following the clock, and you're almost at negative 6 pi over 3, which would be negative 2 pi, a full rotation, but you're pi over 3 away from that. So theta prime is pi over 3. Okay. Number 3 is 11 pi over 6, and you will do that one in class. And number 4 is 225 degrees, and we will do that one in class also. And of course, if you get ahead and you do those, well, that's fine. All right, so I'm gonna say that's gonna be part 1 and stop here, and then I'll continue with part 2.